if you have your unit circle, we're going to reference it a little bit today. You don't have to get it out. I'm just going to reference it, and I'll talk through it. But if you still are unsure of your unit circle, get that out and look at it, and then the things I say will make more sense. If you kind of have an idea about your unit circle, when I say like sine of 90 degrees, cosecant of 90 degrees, then there's no need to get it out. But secant and cosecant is not the opposite of sine and cosine. The opposite of sine and cosine is positive or negative. Okay? It is the reciprocal. It's not the inverse. We're going to do that on Monday. It is the reciprocal, meaning whatever the value is. So if we take the value of sine at 0, whatever the value of sine is at 0, the value of cosecant at 0 is the reciprocal. If we take the value of sine at 30 degrees, that's equal to 1/2. The reciprocal of 1/2 is 2 over 1. Okay, so it's the reciprocal, not the opposite, not the inverse. It's for sure not the opposite because the sign will for sure stay the same. So it is the opposite of the opposite. It is the same, okay? So this first question just says, should there be asymptotes? Talks about, is it continuous versus, or tells you sine and cosine is continuous. And we haven't really said that, but something that's continuous. I think you did that, I'm sure, before in another class, where if we draw sine and cosine, it looks like this. So we can say that's continuous because it goes on and on to the left forever, the right forever. We didn't have to pick up and draw it like when you draw rational functions. They might have a hole, they have asymptotes. We don't have any of that with sine and cosine. But with secant and cosecant, it's possible because 1 over sine x, which if we think about the unit circle, sine of an angle equals y, cosecant of an angle is going to be 1. There are places on the unit circle where y is equal to 0, therefore there's going to be asymptotes. Cosine of an angle is x. The reciprocal of that is secant of an angle, so 1 over x. So there are going to be asymptotes, and it's going to be wherever the denominator, because secant and cosecant's reciprocal, is going to be equal to 0. So wherever the denominator is 0. So for cosecant, it's going to be wherever y equals 0. For secant, it's going to be wherever x equals 0. And do we have to necessarily know that? Yes. Do we have to know on the graph where it happens? We can always plug things in. There's going to be a pattern just like there was for sine and cosine, but if you have trouble with the pattern, you can always plug the value in, evaluate it using your unit circle, and go from there. So because we have asymptotes, it will not be continuous. Okay? If something has asymptotes, now that's for right now. Later on in calculus, you'll learn you have different things that represent continuous. But for right now, secant and cosecant are not continuous because what we draw has asymptotes. We can't draw a secant and cosecant graph without picking up our pen or pencil. Now, I don't want you to get your calculator out, but if I were to graph, let's say, inverse 1 over sine x. Remember, that's have to write it because I don't have a cosecant button on my calculator. So if I were to graph it, this is what the graph looks like. Okay? Now, the calculator doesn't graph asymptotes. I don't know if some of your newer ones do, but mine doesn't. But each of these places where it goes from down low to up high, there are asymptotes. Okay? Those are breaks in the graph. This keeps going on and on forever, just like a sine and cosine. Okay? So it keeps on repeating. We're just going to graph one cycle like we've been doing, but now we have something else called asymptotes involved. So let's look at this first example. There's a couple different ways you can go about thinking of graphing this. I'm going to go with what we've been doing. We've been doing y equals a, now it's cosecant b, x minus c plus d. We have all those parts. So it's no different except that instead of sine or cosine, now it's cosecant. So we're going to have 2 more parent functions today. Now remember, sine and cosine are the only ones that can have an amplitude. Now we still have a. A is still our vertical stretch or shrink. I would never ask you for what is the amplitude for a cosecant problem. I would only ask you amplitude for sine or cosine. Okay, but there's still an a value. Capital A is where you find the amplitude, but capital A doesn't equal the amplitude necessarily. B is what helps us find the period. C is our shift. D, our horizontal shift. D is our vertical shift. So first, I'm going to find the period. the period equals, we're still 2 pi or 360 because the directions say radians. I'm going to say 2 pi over b. Well, in this problem, b is equal to 1. So our period here is just 2 pi. There is no c value, there is no d value. So there's no horizontal shift, there's no vertical shift. So that means we're going to start at 0. We're going to add our period to wherever we started. In this case, it's 0, so our period actually ends up right here. Add and divide by 2, add and divide by 2, add and divide by 2. It's the parent function, and it's the reciprocal of cosine. So those are the same values as our parent function of cosine. Put our y-axis in the correct place. All right. Now, we talked it was going to have asymptotes. So where are those asymptotes going to be? Well, the asymptotes are going to be wherever the function is not defined. Cosecant is 1 over y, right? 1 over y. So really, we're looking for which of these values on our unit circle give us a 0 for a y value. Or do any of them. We know they will because we know there's asymptotes. So think about your unit circle. Think about the quadrantals. This is 1, 0, 0, 1, negative 1, 0, 0, negative 1. So y equals 0 here, undefined, undefined, undefined. So it's going to go back and forth, undefined forever. So at 0, it's kind of hard to do, but you can get an asymptote and a line right there. At pi, there's an asymptote. And at 2 pi, there's an asymptote. Now, that will always happen. That pattern will always happen. For a cosecant graph, that first critical value, the third and the fifth, is where your asymptotes are going to be. Always.
So it's always going to be the left, middle, right?
Mm-hmm. You want to think about it that way? Left, middle, and right? That works too. Left, middle, and right, first, third, and fifth, however you want to think about it. Now, if you can't remember, you can always plug those values in, because remember, we're going to shift it left and right, up and down. So it's not going to always be at pi. Now, I could say, is there a discontinuity at 6 pi? That could be a question. Well, if it happens at 0, happens at 1 pi, 2 pi, it's going to happen at 3 pi, 4 pi, 6 pi, 7 pi, 732 pi, negative 258 pi. So all the discontinuities in this case are going to be pi distance apart. And since 0 is one of those, any integer pi would be a discontinuity. We're just going to graph one cycle. All right, now what I like to do is I like to sketch the sine graph and then go graph the secant from there. So I'm going to sketch very lightly, or actually a dashed line of the sine graph, and that's going to help me do the cosecant, because then I can get that pattern. Because remember, this is what it looks like. What's in this middle part would be like the sine graph. So if I also went here and just did sine x, look how those touch. Those points touch. So if I have that sine graph, then I know just to put those little parabola-looking things above and or below it. Okay, so if this was just y equals sine x, I would have 0, 0. My amplitude would be 1, 0, negative 1, back up to 1. Now remember, this is not part of the graph. This is just going to help me graph the cosecant graph. So either make it really light or make it a dashed line, but don't make it solid, because if you make it solid, that's part of the graph, and then it's wrong. So either really, really light compared to your other one, dashed would be preferable. So now, again, we could come up with all these values, but they wouldn't be pretty. Like if we picked pi over 4, okay, so let's say we picked sine of pi over 4. Sine of pi over 4 equals root 2 over 2. Well, root 2 divided by 2. I don't know what root, I mean, I do know what root 2 is, but let's pretend I don't. I have no idea what the square root of 2 is, okay? But I know that root 2 is less than 2. How do I know that? Because I know root 4 equals 2. So if root 4 equals 2, root 2 is something less than 2. So a small number divided by a bigger number, I know is going to be smaller than 1. But if I flip that, 2 over root 2, now the bigger number's on top. So this point now comes up here. Now, I can't find all of those numbers. Those are ugly numbers to find, okay? So what I do is I just remember what the graph looks like. I know that that sine graph butts up to my cosecant graph, so this is kind of like a relative minimum. I'm going to approach the asymptote, approach the asymptote. And then I'm going to do the same thing for the next section, except now it's down low. Approach the asymptote, approach the asymptote. So it kind of looks like a bunch of parabolas. If you were to graph 2 cycles, and that same thing would repeat and repeat and repeat over and over and over again. So that is what the cosecant graph looks like. If you don't need to draw the sketch of the sine graph, then that's fine. You know what it looks like, whether it's high or low. It is not necessary. Just be sure. I see those 2 points right there. This will never touch each other. These two, there's always going to be a space in between for those numbers that can't be equal. Those y values would never equal cosecant of x on this. All right, and then it says, where are the discontinuities? Well, the discontinuities are going to be at those asymptotes. So for the part of the graph we drew, we take the variable, they're vertical lines. Vertical lines are x equals 0, pi, and 2 pi. Now, are those the only discontinuities? No, they're just the only ones that we drew because we only drew one cycle. Another thing with the graph, be sure when you graph that you don't do something like this. Okay, you're not going to get credit for something like that. Don't do something like that. Okay, that tells me that graph's going right through that asymptote, and it's not. Approach your asymptotes. Okay, always approach the asymptote. Looks like a bunch of parabolas going back and forth. Another thing, I wouldn't ever ask you, we could figure out the domain. We'd have to come up with an equation to figure out the domain on this. But regular precal would not ask you for the domain. But I could ask you for the range on a problem like this. The range would be, this goes down forever, so it would be parenthesis negative infinity up to -1 with a bracket. And then it skips up to +1. To infinity. So we could ask you for the range on this, but I would never ask you for the domain. It's something we could figure out, but we'll do that later on in Unit 6. All right, let's do the parent function of the secant graph. Okay, doing it the same way. Y equals A secant B. Now there's just a theta in the place of an x. That doesn't change anything, just a different variable we can use. So, first thing I'm going to always do is find my period. Period equals, directions still say radians, so 2 pi over b, which is 1, so my period is just 2 pi. So it's no different than what I've been doing, 0, pi over 2, pi, 3 pi over 2, 2 pi. So the period for sine, cosine, secant, and cosecant, just the regular parent function is just 2 pi. If b is something other than 1, that's when it changes. But just the regular parent function, 2 pi. All right, so I draw my y-axis in the correct place. And where are the discontinuities? So we have to think now where on my unit circle is x equal to 0? At pi over 2 and 3 pi over 2. So the second and the fourth, or some teachers say the left middle and the right middle, however you want to think about that. So for the cosecant, it's 1, 3, and 5, or left, right, and middle. For the secant, it's the two middles that we got from the outside and the inside. I always say second and fourth. They will always be there. The secant of pi over 2 is 1 over 0, which is undefined. All right? Now, again, I like to graph the cosine. I'm going to graph the cosine function. So that starts high, middle, low, middle, pi. And again, I'm just going to make that like a dashed line. I'm going to barely graph it. It's just going to help me with my pattern. Now, if I were to go to y equals and change that to 1 over cosine and graph it, it basically looks like the same thing. So just like sine and cosine, if we graph it and we ignore the x and the y-axis, it looks exactly the same. If I were to put in our cosine of x, notice they touch just like they did before. But we don't have the same nice even sections as we did. This one's still the same. That looks like it did before, so we approach the asymptote. Approach the asymptote. The outside are just two little half sections right there. So this is still kind of like think of it like the vertex of a parabola. I mean, it's not the vertex, but if we're looking at just that section, that's what it looks like. So approach your asymptote. Approach the asymptote. And there's your parent function of a secant graph. Now, it would be a bunch of parabola-looking things if we were to continue on. Pi over 2, 3 pi over 2. Let's say I wanted you to list 3 discontinuities, but there's only 2 here. What could we do to pi over 2 to get 1 over there? How far is it from pi over 2 to 3 pi over 2? It's pi. So we could take pi over 2 and subtract pi, which would get negative pi over 2. Or if I wanted another one over here, I could take 3 pi over 2 and add pi, add pi, add pi. A little bit more difficult, not difficult, but more difficult than just the cosecant, but we could do that. Here, the discontinuities on the graph, be sure we say theta equals, we don't want to change the variable, pi over 2 and 3 pi over 2. We're going to take that function, that parent function, move it up, down, flip it, reflect over the sinusoidal axis, vertical shift, horizontal shift. All those things we can do just like we've been doing. All right, so here, A, secant, B, theta minus C plus D. Exact same general form that we use, it's just with a secant and a cosecant. So I like to find the period first because it doesn't tell me to list all these things, but I still have to find the period. If you can do that in your head and don't have to show it, that's fine. But if you tend to make careless errors, don't do that in your head. So since there's a 10 degrees, we know now we're in 360 divided by B, which is 2. So the period is 180. It doesn't tell me to list the vertical and horizontal shift, but I'm going to go ahead and say C equals negative 10 degrees and D equals 3. That's going to help me plot my points. I start at C, so I'm going to start at negative 10 degrees. And then I'm not going to go to 180, I'm going to go 180 degrees. Okay? Go 180, go to 180 are different. From negative 10, I'm going to go 180 degrees, which just means I add 180 to negative 10, and I get 170. Then to find all the midpoints, I add and divide by 2. So 160 divided by 2 is 80. 70 divided by 2 is 35 degrees. Don't forget your degree symbols. 250 divided by 2 is 125. Now, could we have taken 180, divided it by 4 and got 45, and just added 45, plus 45, plus 45, 45, 45? We could have done that also. That works also. If that endpoint messes with you and you don't know why it's not 180, take the period, divide it by 4, because there's 4 equal sections, and just add from there. Put your y-axis in the correct place, somewhere between the positive and the negative. It's always at 0. We're going to go ahead and move up 3. My D equals 3. I like making that a dashed line. It's not necessary. Be sure you label. I'm going to see, do you have your middle labeled 3? Then did you go up 4 to 7 and down 4 to negative 1? I'm going to look for those 3 numbers. And again, I'm going to sketch my, well, no, let's see. I'm going to first put my discontinuous, or my asymptotes. We are secant, so that means it's at 35 and 125. How do I know that? Let's say I didn't know that. I can't remember where it goes. I think it's at 35, but I'm not sure. So let's plug in 35. 35 plus 10 is 45 degrees. 45 degrees times 2 is 90. The secant of 90 degrees. Secant of 90 degrees, that's up at the top. X equals 0 at the top. The secant is the reciprocal. The reciprocal of 0 is undefined, so we put it in the right place. Now, let's say at negative 10 right here, I don't remember what to do. I have no idea where to go. Do I put it at 7, 3, 10? I don't know where to go. So let's plug it in. Negative 10. Negative 10 plus 10 is 0. Times 2 is 0. Secant of 0 is 1. 1 times 4 is 4. Plus 3 is 7. So I know to plot my point right here. Or I just remember the pattern because I am graphing my cosine function just to get the shape. Again, either make it really, really light or just kind of sketch it like that. And now I go to my high and low values and draw the graph. And be sure you approach the asymptote, not the y-axis like I was about to do right there. And there's your graph. Looks exactly like the parent function. It's just our x-axis changed, our y-axis changed. That's all that changed. And then 2 places where f of theta is discontinuous, we could pick the 2 on here. I would suggest that. 35 degrees, 125 degrees. Let's say you messed up. You said this was 25 degrees right here. And then I asked you for the places where it's discontinuous. And you said 25, but really the answer is 35. If you had an asymptote and you named it 25, you get those points off for the x-axis, but then I would grade your discontinuity off your wrong work. Okay, so always, always show as much work as possible, because there's a lot of grading off of wrong things that I would do. If you had the whole x-axis wrong and the whole y-axis wrong, but you had that shape right, then you're going to get the points for the shape. The y-axis, the shape, and the x-axis are completely independent of each other on problems like this. All right, and then the last one, a cosecant. Like yesterday, if that negative one out in front bothers you and you want to move it to the back, you can do that. You don't have to, but then you can see your A, B, C, and D. If you want to label them, if that's helpful, go ahead and do that. All right, so we have the period equals. Now that pi should tip you off. If that pi, really you're looking at the C value, there's no degree symbols anywhere in the problem, so we know we're at 2 pi over 2. I cannot divide fractions, so I multiply by the reciprocal, and I get period equals 8. No.
You wrote
Pi over 4. Okay, thank you. Whew. I didn't remember it being 8 earlier. Thank you. 2, so 2 pi times 2 over pi, period, is 4. Thank you. I'm going to start at my C value. It's the opposite, so that's plus 0.7. This is minus 0.7 or minus 0.7. If you like writing that 0 there, it doesn't matter to me. Now, since the period's 4, there's 4 equal parts. 4 equal parts to 4 are going to be 1. So I could just add 1 each time. Or I could add 4 to negative 0.7 and get 3.3. Add and divide by 2. What's that? 2.6. 1.3. Or I know they're 1 apart. I can label those. It's cosecant if I want to go ahead and put my asymptotes, because I remember the pattern. I can do that. My y-axis is at 0. Asymptote. If I don't remember where my asymptotes are, plug it in. All you have to do is plug the first 2 in. If you plug the first 2 in and there's no asymptote, your x-axis is wrong. You've done something wrong with those numbers. let's see, we went down 1. So there's my new middle. Then I'm going to go up 5 to 4 and down 5 to -6. So again, I'm going to be looking for -6, -1, and 4 written somewhere either off to the side. If you put it on your y-axis, that's fine too. I just put it off to the side so it's out of the way. And then cosecant, but it's negative. So at -0.7, I'm going to be in the middle. Then I'm going to go low, middle, high, back to middle. If I'm sketching the reciprocal to help out. And then I'm going up, approaching the asymptotes. Be sure to approach that asymptote and not the y-axis right there. That can be a little tricky. And then where's state 2 places? Well, we have 3 places that we graphed. It asked for 2 of them. X equals 1.3, 3.3. Or -0.7 and 1.3. Or 3.3 and -0.7. Or if you want to pick something, 5.3, 7.3, 9.3. Any of those would be acceptable. There's an infinite number of correct answers right there. I personally would pick one off the graph, but it's up to you.